Hello, everyone. Welcome to Research on the Road. My name is Michael, and I also have Emily Hyatt here joining me. And today we're going to have our second session on birds, past, present, and future. So I'm going to start things off by covering the past of birds because I am a paleontologist after all. And so my presentation is entitled Birds Gone By because all these guys have gone bye-bye one way or another. So the first bird I want to talk about, if you watched part one, you will recognize this, or if you haven't watched part one, you will probably recognize Archaeopteryx because it is one of the most famous and important fossils ever. And it's also the earliest known bird. This fossil dates back to the Jurassic period, around 150 million years ago. And this animal is unique because it has characteristics of both birds and theropod dinosaurs. Now, in case you don't know, theropod dinosaurs are the bipedal carnivorous dinosaurs, and it's the group that includes Tyrannosaurus and Velociraptor and Utahraptor and Allosaurus and all those famous big scary meat eaters. And as I mentioned in part one, birds are actually living theropod dinosaurs because they're so similar, you can't even tell them apart. But on that note, Archaeopteryx has a mix of traits of both theropods and birds. And because of that, the consensus on whether this animal should be considered a bird or a dinosaur has gone back and forth in the literature for the past 150 years. And so this is, as well as many other species similar to it, is an excellent example to help illustrate that the link between, or the gap between birds and dinosaurs isn't a gap at all. It's a continuum between those groups. Another dinosaur-aged bird is Hesperornis. This is an interesting creature. So this is actually another toothed bird. So like Archaeopteryx has a long bony tail and teeth in its jaw, unlike modern birds. Hesperornis also has teeth in its jaw. It also, and you might think it looks kind of like a penguin, and it kind of lived like one. It had flippers that were formed from very highly reduced arms. And when I say reduced, I mean the bones in the arm become like really small or even disappear in some cases. And so this animal, so in our arms, we have the humerus, we have the radius and ulna, or the scapula, humerus, radius, and all the hand and finger bones. And birds also have a similar thing. They don't have as many fingers as us, but they still have some finger bones, believe it or not. But this creature only has a scapula, the shoulder blade, and a very weird, long, skinny humerus that's not really doing anything or connecting to anything. And this would have formed a flipper in life. But most of its power when swimming was coming from its hind feet. So these animals, like penguins, were excellent divers, but pretty awkward on land. And when they were on land, there's some evidence that suggests that they would have actually moved more like seals, crawling on their belly and pushing with their hind feet, rather than walking straight upright like a penguin. Although this is not for certain, and it's an area that needs more research. But right now, it seems like it can kind of go either way. There's evidence for both of these models. So after the dinosaurs went extinct, life was quick to fill the place of these giant reptiles. And so since you didn't have any big apex predators around anymore, you had to have things that filled the place. And one of those things were the forest rakids, also known as terror birds. And that is a very apt name because these things were terrifying. I mean, so these were predatory flightless birds. So think like an ostrich on steroids that like ate things, that ate meat. The largest species stood about 10 feet tall, so it's almost 2 of me high. Very fast runners. They had very powerful jaws and a sharp hooked beak like a raptor to quickly dispatch prey. And I just learned this very recently, but there's some evidence that apparently suggests that much like owls, these terror birds would have swallowed prey whole and then later regurgitated what they couldn't digest, like bones and fur and stuff. Now, this is tentative. You notice I put possibly in italics because the evidence is unpublished. So it's basically hearsay at this point until it actually gets in a reputable scientific journal. But very big if true. And these animals are related to modern day Seriamas from South America. And we go to places like the Los Angeles Zoo, which is near me, you can see Serialmas, and they're one of my favorite living birds because they actually have little like raptor sickle claws on their feet if you look closely. Neat little animal. Okay, moving on. Pelagornis is another interesting critter, and you'll see why shortly if you don't already see why. So this animal lived well after the dinosaurs went extinct in the Neogene period, starting about 25 million years ago, going extinct fairly recently, 2.5 million years ago. These guys were seabirds, basically, and they were close relatives of pelicans and storks. And if you notice in this illustration, it's kind of small, but the beak is kind of interesting. And I have another picture here. And you notice, oh, it's another toothed bird like Archaeopteryx or Hesperornis. No, actually. So these are called pseudoteeth. These are not teeth at all. So teeth are actually set in sockets inside the gum line, but these are just simply extensions of the keratinous beak that just happen to look like teeth. And so there's actually, I don't know of many birds that have this today. It seems to be more common in this group in the past, but there is at least 1 or 2 species of hummingbird that actually have like a serrated bill that's not teeth, but just it's an extension of the bill. And Pelagornis shares the honor, or it has the honor of being the largest bird of all time by wingspan. We'll move on to the other largest bird of all time later. But this animal had a wingspan of 21 feet. When you compare the largest wingspan of a bird today is the albatross, which caps out at like 10 feet. This is a pretty big animal. Another pretty big bird were the teratorns. This is a group of animals. And the fossils of these animals date from about 25 million years ago to 10,000 years ago, which is very, very recent in geological terms. These animals at first are similar in appearance to condors, but they are significantly larger. So to clear up a misconception here real quick, if you Google these animals like teratorns or a specific animal called Argentavis, you're probably going to come across the fact that they had wingspans of like 20 to 25 feet or something, but that is actually based on some outdated information. So here you'll also probably come across this illustration if you just Google the term teratorns. But this silhouette is, again, it's based on some older measurements that we don't think are quite accurate anymore. So the wingspans are more likely to be 15 to 18 feet, which is still really big. Now, teratorns are traditionally thought of to be scavengers, much like condors and other vultures. But if we take a closer look at their anatomy, we realize that might not actually be the case. So a paleontologist and paleoartist named Mark Whitten wrote a piece called "We Need to Talk About Teratorns," which I recommend looking up if you're interested in digging more into the details of this, but I'll briefly cover his points here. So Whitten looked at the skulls of these animals. So these top 2 skulls that you see are those of modern day vultures, I think from both New World and Old World vultures. And the bottom skull is one of these teratorns from the La Brea tar pits here in Southern California. Now, I understand why. I mean, for a long time, I just kind of went with the consensus and assumed, yeah, these guys are scavengers because we've analyzed how they fly, and they did a lot of soaring, just like modern day vultures, riding air currents. They have a long hooked beak that would be good, just like in modern day vultures, for tearing hunks of flesh off. And the cherry on top is that a lot of these fossils are found in the La Brea tar pits. And if you don't know, the La Brea tar pits are they're basically an animal trap. So animals got stuck in asphalt and died, which would attract more predators, and they got stuck and died, which would attract vultures. And you find lots of these guys there. So the evidence is piling up. But when you really look at the skulls, we realize that that's not, the case isn't as strong as we might have thought. So first of all, they have shorter and more robust skulls than a lot of vultures today. And raptors today, not like velociraptor, but raptorial birds of prey, their skulls are highly influenced by morphology. So how they use a skull will influence what the skull ends up looking like in the species and in the families and all that. And it turns out that the skull of these teratorns is actually more similar to piscivorous raptors today. That is birds of prey that eat more fish than anything else. Now, that's kind of weird because when you look at the bone chemistry of these guys, it actually turns out that they were primarily eating terrestrial animals. So Mark Witten hypothesizes that they might have spent time on the ground because it also turns out that they have some pretty strong legs, not enough to grab stuff and carry it away like you think of eagles doing, but they were clearly comfortable walking around. And so Witten says that they might have had habits like herons and cranes where they kind of walk around and swallow stuff whole, like little bunny rabbits and other small mammals, and rather than being a vulture type animal. So it does seem to be more of an active predator. But because this is a blog post, albeit a well-informed and well-researched blog post, it's still not an actual scientific paper. So more study is needed on this. Elephant birds. This is another animal you might have heard of. And you'll notice a little asterisk there for any other bird you see that I talk about today with an asterisk next to it means humans wiped it out. So this is going to be kind of depressing from now on. But elephant birds are a pretty well-known bird. They are the largest flightless bird ever, largest bird ever. These things can be up to 10 feet tall and 1,500 pounds. That's 3/4 of a ton. Like, that's as much as some cars weigh. These are big birds that do not live on Sesame Street. They actually live in Madagascar. We can study what their brain shape looked like, and we can tell if these animals were probably nocturnal or crepuscular. Crepuscular means that they were active in the morning and evening before the sun was up or completely set. And their eggs are famously ginormous. So I mean, they would have literally fed entire families. And so the volume of one of these babies is equivalent to about 150 chicken eggs. Like, think how big of an omelet you can make with this. And sure enough, we actually find evidence of some broken eggshells near remnants of fires, or what's left of fires. So, I mean, families were actually hunting and cooking these things, the eggs at least, which probably led to their extinction because they all went extinct about 1,000 to 1,280, somewhere around there. Another big bird is the moa, which again, you might have heard of. So these were not only flightless birds, but they were actually wingless. So even flightless birds today, like elephant birds or ostriches, emus, cassowaries, they still have wings. And sometimes if they run, they'll use them to steer and stuff, or they'll use them for display, or just not do much of anything with them. But these guys don't have any arm whatsoever. They don't have radius and ulna. They don't have a humerus. They don't have a scapula. Nothing. It's just like, it's weird. If you look at the skeleton, it's just like the ribs. But these animals lived in New Zealand, and what was unusual, a lot unusual about them. So living on an island, you get a lot of weird stuff happening, and I could go in for an hour about all the weird stuff that happens to animals on islands. But these guys turn out to be grazers. So they essentially, these big birds, took the place of like deer or cows or antelope, because there were no deer or cows or antelope on New Zealand. And so they, were consuming this very fibrous, tough plant material like grass, for example. And these animals had, because of their size and because they were on an island, they had very few predators, with one exception. And that was, as you can see in the upper right corner, the Haast's eagle. Really big eagle. This thing weighed like 35 pounds compared to the harpy eagle today, which is the heaviest eagle alive, I think, at 20 pounds. So these things were 1.5 times as heavy as the biggest eagle alive today. These were terrifying, big, flying monstrosities that were eating these like 7 to 8 to 10 foot tall birds. And another interesting thing about the moas is the position of the head. So we can tell by looking at the skull that they probably they would have held their heads horizontally like a kiwi. So they're like think of it like a 1 or 1/2 ton kiwi. But if you can make out this cave drawing or cave art in the lower left corner, the native Maui people have illustrated these animals with their heads held upright. And these are actually from the time of moas. So these people actually saw moas and illustrated them. So the moas probably were able to hold their necks straight up too, and they're probably comfortable at either orientation. And so this is kind of, there's a lot of sad stories here. This is one of the many sad stories, because after the ancient Maori people got to New Zealand, the extinction of moas took about 100 years before they were all wiped out. And by the year 1445, all the moa were extinct, as far as we know. And this was soon followed by the extinction of the Haast's eagle, because once the ancient Maori hunted the moa to extinction, these big predatory eagles didn't have anything to eat, and so they went extinct as well. So it kind of had a ripple effect with the ecosystem. And as you can see in the bottom right, in a Superman comic, a moa flew with its feet, which is interesting. Okay, Dodo. This is probably the, next to Archaeopteryx, probably the most famous or well-known bird I'm talking about today. So this is actually, one of my favorite fun facts about this guy is that it's actually in the pigeon and dove family. So its closest relatives are pigeons, despite it not looking like a pigeon at all. So this is a big flightless bird, pretty big. So it was a lot bigger than even like large turkeys today, about 3 feet tall, and could be like 35 pounds. So pretty stocky animal. Now, these guys are well in popular culture, and you might, I haven't heard this phrase for at least 15 or 20 years, but when I was growing up, I remember I heard the phrase like dumb as a dodo. And so these animals are famous for being, you know, stupid and clumsy, but that doesn't actually seem to be the case. So they, looking at the shape of their brains, they're probably about as intelligent as modern pigeons. And modern pigeons, in case you don't know, they're not stupid. I mean, birds in general are pretty smart, and pigeons, like, they have some problem-solving capabilities. They're also depicted as, you know, slow and clumsy, but they actually have powerful legs and were probably, they were well adapted to their environment, just like any other animal. Other than that, however, very little is known about their behavior because the European settlers didn't take a whole lot of notes on these guys. They kind of just, you know, killed them. And it's not so much they were wiped out by humans for human food, but dodos are primarily wiped out because of human introduced invasive species like pigs and dogs and cats and crab-eating maquis, that's a type of monkey. And so these animals would have
Rats. gotta interject with that one. Rats are a huge invasive island species.
That's true, yeah. So these animals would have eaten the eggs of the dodo and competed with resources. And again, just like the moa, this animal went extinct less than a century after it was discovered. And the last known sighting is in 1662. So that's another one we wiped out. And just get ready because there's a few more. Next up is the great auk. The species name is Penguinus impennis. And I want to mention that because you might think, oh, it's black and white. Its scientific name says penguin something something. So it's like basically a penguin, right? But no, actually. So these guys, so they belong to a group called auks, which is still alive today and includes puffins and a bunch of other birds I don't remember the names of. But puffins are, you know, puffins and their relatives, basically. And they're actually completely unrelated to penguins. But the reason that penguins are called penguins is they're actually named after this species. Because sailors, when they got to Antarctica, saw, hey, those look kind of like auks. And the auk's name is Penguinus, and there we go. So the worst trait of the auk for its survival, it turns out, was its very soft, beautiful coat. Because it was highly sought after by Europeans, and, you know, bang, bang, boom, it went extinct in 1952. But what's interesting is that this species actually inspired some of the earliest environmental legislation protecting species. But that wasn't enough because we still killed them all. Last but certainly not least are the passenger pigeons. This is a truly sad story. I mean, all of these are, but these were very, very recent. So the passenger pigeons were a species of migratory pigeon, and they formed absolutely enormous flocks. I mean, they were probably tens or hundreds of millions of these things in the North American continent in the 17 and 1800s. And passing flocks were so big that they would darken the sky for days at a time and could be heard from miles away. I mean, it's hard to understate how many of these things there were. The flocks were so dense that an unskilled hunter just pulling a trigger and shooting in the air could get 6 of them in one shot, and a trained hunter with a double-barreled shotgun could get over 60 in one blast. And so they would get, you know, barrels, and just when flocks would go overhead, they would just shoot them and collect huge barrels full, usually to eat them or to feed the pigs or something. But it turns out that passenger pigeons, these were a very, very common and they're a very common animal. So you'd expect that it was important to its ecologies. And it turns out modern ecologists consider this animal a keystone species that influenced the evolution, the structure, and species composition of entire forests. Because this animal, when they would roost a long time in certain places, they would break down tree branches because of the weight of these animals constantly on the branches of dead trees. Their dung would accumulate and basically kill all the vegetation below it. And all these dry, dead branches and dried dung and dried, dead plants would actually contribute to more forest fires in these areas. These animals, they ate primarily acorns and stuff like that. And so it actually influenced how, like, some trees grew bigger acorns, like red oaks. White oaks actually changed when they blossom to the fall when these animals aren't around. So, I mean, it's hard to understate the impact these guys had on, like, entire forest systems in the eastern United States. But because humans are insatiable, we wiped all of them out. And the last wild member was shot in 1901. And the last surviving captive individual, named Martha, as you see a photograph here, died on September 1st, 1914. And I can't even fathom how it would feel on September 1st, 1914, how it would feel to know that you are literally witnessing the death firsthand of an entire species. I mean, we're seeing that today all over the place. And, this could be a whole other topic about, conservation stuff, but I have Emily here for that. He's talking about conservation. And so I'm going to turn things over to her.
All right, thank you. I was just, I wanted to add to the beginning of my presentation a quick picture that I've seen on passenger pigeons, just to kind of illustrate the point of how much impact humans can have on a single species, and how we don't think of our actions as being something that can actually wipe out a species, but it absolutely can. So I will start with my presentation here, continuing last week's bird conservation theme and going more from a perspective less on the history of bird conservation and more on how we're doing it today, what we're doing now to continue to allow these birds to thrive now that we've taken care of, we've addressed some of the issues that have threatened them, like we saw last week with the DDT and the pollution. We've identified and addressed some threats, but there's still a lot that they face. And so this is what I just tossed in. This is a depiction. It's an artist's depiction of the descriptions that pioneers and past residents of the Western United States used to describe passenger pigeons as blocking out the sun. And they would be so thick and abundant that it would cause a shadow, and you would look up and just see a huge flock of them. And so, like Michael said, they were wiped out by hunting, by over harvesting, and it was excessive, and it was not so much to feed people who needed it as it was a sport. And enough of a sport that this kind of harvest would take place, where people would kill as many as they could. My cat Charlie is saying hello to you, and she's saying that it's best to protect the birds and keep your cats indoors. This is a mound of passenger pigeons that have been shot and collected. And you know that these are not going to be put to use. They're not going to be used for subsistence or feeding someone who needs it. This is just a trophy. So now I'm going to go into bird migration, because bird migration is an interesting aspect for conservation, because it's difficult to, it's all well and good to be in the United States and have laws that we set as Fish and Wildlife, our conservation authority, and we're good at protecting the threatened species that live in our borders. So the species that live in the United States, we can do what we can to protect them. We can limit hunting, but that doesn't mean they're always safe. The same bird that comes to the United States and that we enjoy seeing out our window is the same bird that is migrating halfway across the world at the other times of the year. So how can we ensure that they're protected whatever time of the year, wherever they happen to go? Because almost 20% of the birds in the world are migratory species. It's very common for birds to migrate and to have long distance migration. We've identified about 10,000 species of birds, and we're pretty sure that about 1,600 of them are migratory. And that's land birds, but also water birds. So a lot of the shorebirds that you see are only there at certain times of the year. They travel back and forth. They have nesting grounds and feeding grounds. In 2008, 11% of the land that is identified as necessary for migratory birds So the birds that are on the IUCN Red List, 11% of the land that they occupy is threatened. So they are not in the clear just because the IUCN Red List lists them as endangered or threatened, and that means that they're afforded protections, but we can't always ensure that those protections are in place across the world. And so most of our migratory species, so most of those 1,600 species we've identified, are really widely dispersed. It's not a short migration, it's a very long migration. It could be across from equator to the polar regions, and that's a common migratory path for birds. So our efforts to conserve them need to address this. We need to know how we can protect them when they're here and how we can protect them when they're elsewhere. Because if we want them to return, we need to be sure that where they go is safe as well. And so a lot of this has hinged on international collaboration efforts. And so there's a lot of coordination between nations that both have an interest in protecting these birds and wanting to see them thrive so that we can share them. They can be here and they can be there, and we can all enjoy and protect them and hope that they continue to travel back and forth. So just as a representation of how far migrations can go, we're talking outrageous distances. The Arctic tern has the longest known migration, 60,000 miles. This is in a year. So that's circumnavigating the globe and then some. Shearwaters are in second place, but it's kind of a distant second. I mean, they're a third less miles traveled for the second most traveled species. So that Arctic tern is just pumping it. It's zipping around the world. And even penguins have pretty decent migrations. You don't think of them as being long distance travelers because they can't fly, but they still migrate. And so these migratory birds are threatened by a lot of human impact. And so agriculture is a big one because we're destroying habitats. Hunting and trapping is obvious. We are deliberately killing these animals as sport, and not as much for subsistence hunting, more for the fun of it. Logging and wood and plant harvesting is, again, habitat loss. And invasive species, like Michael mentioned, invasive species are very harmful to birds. They tend to be susceptible to population loss and threatened the species wide. So they're threatened by extinction just by having competitors and predators introduced in their native range. So there's quite a few issues that they're facing. And so this bird, our friend the bustard, likes to use what is turned into farmland. So birds that are migrating aren't just crossing paths with people flying overhead and going to the next wild spot over. they want to use that spot whether or not we like it. So if we identify an area as good for agriculture, we want to use that for farming, but that has long since been the native range for these bustards to use. They're going to continue coming there. And if they can't continue coming there, it might actually threaten their livelihood. They might not be able to survive. They might not be able to have other options. And so often, because agriculture is sort of can be a family run sort of thing, and it is definitely important for people's livelihoods as well, it can be difficult to work with landowners. So there's a lot of issues there that are not just industrial issues or political issues, border issues. It's also that these people need to be taken care of as well. We can't say that these birds' lives are more important than the people who own this land and use it for their own good. So it's a complicated issue, and a lot of times we have to compromise. So the Migratory Bird Treaty Act was enacted in 1918, a bit late for our passenger pigeons, which, as Michael said, were wiped out shortly before that. It's basically prohibiting killing any migratory bird. And it's not just killing, it's collecting. You'll often see this cited, a law that says you can't even pick up bird feathers that you find on the ground, that you are technically breaking the law when you pick up a bird feather, because you cannot have any part of a migratory bird that is considered collecting. So next time you pick up a feather, think about it. You're not actually harming any birds, but you might actually be breaking a law. So this is fantastic because this is international between not just the Western Hemisphere with the United States and Mexico, but also across the Atlantic into Great Britain, across the Pacific into Russia and Japan. And so this covers a lot of ground, and it covers a lot of species that use these areas and travel back and forth. And so that's fantastic, but it's not quite enough. I mean, you think, yes, these are powerful countries, these are widespread countries, but that's hardly the entire world that we're protecting. So bird migrations, we know the preferred routes. We've done a lot of research to identify where birds go, different species, and there's a lot of overlap. There's a lot of different species that use the same flyways. So there's pretty much 4 that we've identified that are the general, a lot of bird species have them in common. So there's the Americas, there's one between the African and Eurasian region, there's a Central Asian flyway, and then there's one that is spanning East Asia and Australasia, so the Indo-Pacific area over there. And these are the basic idea of them. These are our pretty standardized models of where birds go from one time of the year to the other. But it's not just that there's differences in where they go. It's really nice that we can pretty much understand where they're traveling to and from, but we also need to know when they're traveling. And that's not necessarily standard either. So it's seasonal, but it's also, even within a season, it's specific to species. And even the time of day will vary. So there's some birds that travel during the daytime, like pelicans, storks, birds of prey, swift swallows, finches. They travel during the daytime. You'll see their flocks flying overhead in the middle of the afternoon. But then some birds prefer to migrate at night. They'd rather have darkness while they are doing the bulk of their traveling. And water birds, cuckoos, flycatchers, thrushes, warblers, orioles, and buntings, those are considered nocturnal migrants. So we have to be particular to location, to season, to what part of that season, and then also what time of the day if we really want to protect them. We need to know as much as we can about these species in order to adequately cover them. And an extra complication into that is that spring is we have it set on our calendar. We have spring starts March 21st, but that doesn't mean that the temperature is exactly the same. So what we recognize to be spring is not what these birds are recognizing as spring. They're not picking a date and traveling then. They're picking a temperature range where they're comfortable, where they feel things are warming up, and it's time to start their migration. So that changes now year by year because of climate change. So this is a typical cycle that we're seeing. So they're pretty much, usually it's the summer. The summer is the breeding season. The winter is when they're in their overwintering season. So they are breeding in the areas that they would prefer to spend they would prefer not to spend a winter in. So and then between those, in fall and spring, they are traveling. So in the summer and winter, they've picked their destinations and they're spending time there. Spring and fall, they're typically on the move. So hunting, of course, is a big detriment to bird populations. The United States is pretty good about regulating hunting. We don't outright restrict it if the species aren't threatened or endangered, but it is regulated. There's seasons to it, and there's limits to how many can be caught. So that is fairly well monitored. And the U.S. Fish and Wildlife Service, hunting not just of birds, but of all game species, is well regulated. And so we also incorporate in that enough research that we can say it's not a standardized, all birds are fair game at this time of the year. We know when they're migrating, when it's unfair to hunt them, and when the numbers are not going to be a significant population loss if we allow hunting during those times. On top of that, though, hunting itself is not, it's a reduction in population, yes. So shooting a bird means that bird is lost, and that is a shame. But hunting as an action, as a sport, does more than that. The birds who aren't killed are also affected by it. Stress can cause them to lose body condition. They can actually die and have higher mortality beyond that time when the hunter was there, just because they've been stressed. If you hunt a prey species or a predator species, you are changing the environment for their own prey or predators. So you're taking food from a predator, or you are removing a predator, and perhaps there will be an overabundance of prey. So there's a lot of ecological factors that go into it, that it's not just taking one animal, you're affecting the entire population. Vultures have other effects beyond the hunting itself. So if hunters aren't even targeting birds, they might shoot an animal and leave the carcass. And if they're using lead bullets, a vulture, some carrion species, might come in and eat that carcass and eat that lead bullet. And they can get lead poisoning just like any other animal can. And so that has actually been a big problem in the Western United States, where lead bullets are commonly used, and also in Africa. So in Africa, there is actually deliberately poisoning carcasses and trying to get rid of the vultures. So we're kind of doing it by accident, by leaving lead bullets in the environment for them to consume. In Africa, it's a little bit more deliberate. They would prefer to remove these vultures from their habitat. And so Michael brought up the condor earlier, or a relative that resembled the condor. The condor, it was highly affected by DDT, like we talked about last week, and it's still recovering in terms of population. It was essentially extinct. They went out into the wild and rounded up every last California condor, brought them into captivity, and started their own breeding program. And that's the only reason we have wild condors, is thanks to conservation efforts to breed them in captivity and re-release them. Unfortunately, they too are scavengers and are affected by these lead bullets. However, despite all the threats, there's reason to be optimistic because there's so many international efforts that are devoted to protecting birds. In the Western Hemisphere, we have the Shorebird Reserve Network, specifically for shorebirds, but that's because so many shorebirds travel to the Arctic for their breeding season. And then when it's a bit too cold in the Arctic, they fly south for the winter and go down into the areas that we're more likely to see them down in North and South America. And so all of these blue dots on our map here are protected sites. We know those are places where these shorebirds like to congregate, and we protect them specifically for those birds. Partners in Flight is another great one that's also in the Western Hemisphere. That one is between the US and Canada for their breeding grounds, but it also incorporates the Caribbean, Latin America, and Mexico, Central American region, where they are more likely to spend their winters. So there's quite an effort between governments. They get conservation groups, and they even get businesses to join. And so anyone who is invested in and cares to protect these birds is able to join and participate, and it becomes a significant effort in protection. We do have to be cautious, though. I mean, there's reason to be optimistic, but we have to be aware of how our choices affect birds, not just when we see them outside, but how that affects them as they travel and how that affects all the species that they interact with. So just as a reminder, we're still in April here, it's still Earth Month, and April 22nd is Earth Day. So always a good idea to think about the birds and to protect the birds as best we can. Put out a bird feeder, get a hummingbird feeder, get a bird bath. They're always fun to appreciate from a distance or from close up, as long as you're kind. And that is it. That is my presentation. So thank you so much for tuning in. I hope you guys learned a lot about birds between these 2 weeks. And if you want to catch up on last week's video, we have that up on the website on our live stream page. And I hope to see you again next week.
Bye. Thank you, everyone.